Pre-Calculus 1.13. This is just, I call it 1B. It's the same unit. We're still analyzing functions, analyzing graphs. So it felt awkward calling it Unit 2, but I didn't want to have the test be after the quarter. So at least traditionally it's a long unit. So just so you're aware, in Algebra 2, some students would struggle with graphing a function like this. And the reason why they struggle is understanding where the vertex is, what's the slope of these, where they intersect, things like that. And the real reason why is because of this piece right here, this times 2 that's in front. Now, you do have access to a graphing calculator, whether that's just using Desmos or an actual graphing calculator, but let's investigate that real quick. So I just pulled up Desmos, and right here I can type in y equals, right now you can't see it in the screen, but in the bottom left here there's this little show keypad, and right now it says hide keypad. But this button right here will create the absolute value. 2x plus 4, and then close the absolute value, and I already forgot what the value was, minus 3. So minus 3. So what you can see here is that the vertex was actually shifted only left 2. And that should make sense, because what you could have done is factored out a 2 between those two things, and then you'd have x plus 2. Maybe I'll write that out for you. Factor out a 2, and then you have x plus 2, and then the minus 3. The other thing that you might notice is that the slope of this kind of looks like it's going up 2 over 1, up 2 over 1. And same thing with the other side. And some people would describe this as a vertical stretch, but what is actually being done here is it's a horizontal compression. So instead of going up 1 over 1, it's cut in half. So it's like up 1 over 1 half. So this is what I'm going to copy over to the other function. So my vertex is at -2, -3. And then right here, here, here. I think that's enough points. But what I'm going to show you is a different way of finding the equation of absolute values without having a graphing calculator. What you'll probably notice is that we could write any absolute value as a piecewise function. And that's what we're doing. So we're trying to prepare you for calculus and understanding absolute value functions. So we usually read this left to right. So you would want to write x, the x value that is less than -2. I guess maybe I'll use a highlighter to show you what I'm talking about. Find a highlighter. Is we have two pieces, a line that's to the left of -2, that's what I'm trying to highlight there, and a line that's to the right of -2. And I could color, maybe get a different color highlighter and point out that we're going to do this piece for the top one, and then here's a different color highlighter is going to represent the right or the bottom of my graph. So what's the slope of my pink highlighter? It's definitely going down 2 left 1, so make your equation -2x. And then what would the y-intercept be if I continue down? Well, if I kept going down 2 over 1, I'd be at -1, -5. If I have to go one more time to get to x equals 0, that's -7. And now I need to do the same thing to the right of -2. And if I'm looking to the right of -2, this time my slope is +2x. And now my y-intercept you can actually see and you can identify as +1. Now technically my answer is wrong, because right now I would have an open circle at this point. And I've seen math teachers put an equal to on both of them, but I think that's a bad habit to be in. Just choose one of them, because no matter what -2 you plug in for x, you get the same value. Like this is 4 minus 7 is negative 3. If you plugged it in here, you'd have negative 4 plus 1, which is still negative 3. So just choose one of these constraints and put an equal to on it, and then you should be fine. So what we're going to do is show you a method that without a graphing calculator you can get this answer, and without understanding the transformations, because that was, section 1 of chapter 1, and we're in section 13. So here's a step-by-step guide, and you might want to be paying attention at this point, is start by setting what's in the absolute value equal to 0. And that probably is similar to what we did when we did the unit on transformation. So subtract 4 over and divide by 2, and you get the x value as negative 2. So now what the suggestion is to draw a number line. So we know number line. And you don't have to write down 0 this time. At least one of my classes, I make them write down 0 every single time. Not in this class. And what you're going to do is just randomly pick a number that's to the left of negative 2. I guess I should have clarified that. I wrote down negative 2 because of this value. So a number to the left of negative 2, how about I change colors as well? Number to the left of negative 2 is negative 3. And a number to the right of negative 2, I'll just do negative 1. Some people would do the easiest number possible. Like they might choose 0 over here. And multiplying by 0 is really easy. That's why some people will do that. And what you're going to do is take the equation they gave you. All right, I'll highlight the equation I'm talking about, f of x. And what you're going to do is just plug in that value into the absolute value part of the graph. So here's the premise, is as you were to look at 2x plus 4 minus 3 and plugged in a negative 3 right here, what you get, and maybe I'll write it down here because I'm kind of doing step 3, is you get negative 6 plus 4, and negative 6 plus 4 is negative 2. And the absolute value changes sign, so it becomes positive 2 minus 3, which equals negative 1, which is definitely the correct answer. But what the premise is that with the negative being placed here, and we got a negative for the absolute value, we want to change the sign of it. So instead of writing absolute value, I'm going to put parentheses, and I'm going to distribute that negative in there. I don't like my arrow being right there. Let me get rid of that. So distribute that negative. So I have negative 2x minus 4 minus 3. And when I simplify that, I'll go back to purple so it's really bold for you. I get negative 2x minus 7. Well, where have we seen negative 2x minus 7 before? That was the equation of our top piece. For, I don't know why this went away, x is less than or equal to negative 2, which is exactly what we did. X was our bound. To the left of that gave us a negative. Well, I can say the same thing about the right side. Okay, so again, I'm looking at that equation that we gave us. But look at what happens when we plug in negative 1. So I'm going to jump down here. If I plugged in negative 1 right there, I would get negative 2 plus 4, which is just positive 2. So what does the absolute value do to a positive number? Absolutely nothing. So what I'm saying is don't change the sign of this absolute value. Oops, I changed colors too soon. In other words, it's still a positive, so there's no need to switch the sign of that. So we're looking at just 2x plus 4 minus 3, and when we simplify that, we get 2x plus 1. Well, where have we seen that equation before? That's the bottom half. And you can see that my constraint was still true. That is values to the right of x equals 2, negative 2, excuse me. So what we could do, once we simplify that, and we can rewrite the function as a piecewise, where values to the left of -2 write -2x minus 7, and values to the right of -2 we can write 2x plus 1. And again, technically my answer is wrong because we need to define it for one of these two, and it doesn't matter which, just choose one. I'm doing the top one. So how does that compare to the one above? They are the same, they should be the same. I'll leave it to you to explain, how you do that. You could say something as simple as, well, we both define them using f of x, so they're the same function, something like that. So as we move on to the next slide, you can see why, like, a lot of students have struggled with, what do you mean x plus and an x minus? I have no idea what this graph would look like. And that's why we have the step-by-step process for you. Is it shifted left 4, up 1? What's going on here? And we'll look at the graph in a little bit. But the clue is to set each absolute value equal to 0. And so when you solve this, we have x equals -4 and x equals +1. I hope you can do that in your head. So now draw a number line and just split it up. And it's advantageous to go in order. So like -4 needs to be written before +1. And again, try to be smart about what you choose for your values. Like, don't write -1,000 if you don't feel like plugging in -1,000 into those values. I gave you that hint that 0 is a common number that people like to play with. And then the easiest number after 1 for me is 2. So as we look at each one of these pieces, we're looking at x plus 4, and we're looking at that x minus 1. Well, let's think about, if I were to plug in -5 in for each of these values, well, -5 plus 4 is -1. Does the absolute value change? Well, yes, the absolute value changes a negative to a positive. So when we're looking at this piece, we want to do the opposite of x plus 4. And the same question goes, if I plugged in -5 here, well, -5 minus 1 is -6. Does the absolute value change that? Yes. So we want the opposite of that value. So as I'm looking at that, I need to distribute my negatives. So negative x, that's -2x. -4 plus 1 would give me -3. All right. I'm trying to color code, by the way, and help you like visually see everything. All right, so I'm going to switch colors. So what about x equals 0 in for this? X plus 4 and x minus 1. So let's plug in 0 right here. Well, 0 plus 4 is 4. Does the absolute value change? No. So we're going to leave that as just x plus 4. What about plugging in 0 for this x? Well, 0 minus 1 is -1. Now the absolute value does change. So we want the negative of that value. So as I'm looking at that, x minus x will cancel each other out, but 4 plus 1 will give me 5. So this middle piece, from -4 to 1, sorry, my picture's getting a little messy here, it equals just a horizontal line. And I'm running out of time, but I really should not rush this. We're doing the same thing with this next one. I'm just going to work without explaining, and when my time runs out, I will pick you back up on the next video. So this is going to be a positive term, because plugging 2 in gives me 6. The absolute value of 6 is still positive. And this is also positive. 2 minus 1 is 1. It's positive, so it does not change signs. So as I simplify that, I get 2x. 4 plus -1 is 3. So my time is up. I will catch you with how to finish this problem.